Hello, my name is Ygor. My talk today will be about Azure Speech and text-to-speech in general using Elixir.
Welcome to the Speech Alchemist talk.
Whoops, sorry.
It was like she was screaming, but she should have screamed, but she did not. This was like also generated using the API. A little bit about me. I'm a lead software engineer at DPR Media, together with Tonchi. Tonchi is like also from my team. I'm building my own company. Hope I can launch it like next month. About like recruitment specific for Elixir developers. That should help you find an Elixir job, I hope. I have like 13 years of experience with development in general. I work with so many languages, like Java most of my time, C#, Scala, you name it, .NET. I also maintain like a couple of libraries. One is Revix. It's a driver for RavenDB, written in Elixir also, and also Revix Ecto, which is like an Ecto over Revix. RavenDB is also a really nice database for documents. It's pretty nice, nicer than MongoDB, I would say. I'm also maintaining Azure Speech and Azure Language, which implements pretty much the whole API from Azure, both for text-to-speech and also for language processing, tokenization, sentiment analysis, pretty much everything. I like cats, of course, everyone likes it. And I love annoying software architects. I hope no one of my company is watching it. Of course, I am. And what we will cover, the challenge of like implementing Azure Speech in Elixir, and why did we do that? A journey from the REST API to the WebSocket. Explain like also why we choose Elixir for this, and a deep dive on the architecture. Comparing also with the original TypeScript SDK. And advantages, like if I will compare some TypeScript, so prepare to do that. Like if you have like a faint heart when you see your JavaScript, I suggest you to leave now. And challenges faced and lessons learned. Why does matter? Because there's no official SDK for Azure Speech. It's an opportunity to really show the Elixir strengths when comparing to other languages. It's a valuable, also a lot of valuable learnings on how to use Elixir for this kind of application, like audio. I think we had a talk about like using Elixir to create MIDI files, which was also like interesting. So we can learn a lot with this. Let's start with what's the Azure Speech SDK. It's a cloud-based service that has like a text-to-speech, speech-to-text, translation, speaker recognition. It's available in several programming languages. Sadly, not in Elixir or Erlang. Why to implement in Elixir? The concurrency model, of course. You can see a text-to-speech pipeline. How does it work? You get like a text or a full text if you want, and it will fire up to their service. You will get back an audio file. And this audio file can be a stream, can be a full file, and you can possibly have like thousands of those in parallel, depending on how do you work. In our use case, we have roughly 100 to 200 requests in parallel on the text-to-speech, and it runs in one node with less than half of a CPU and 256 megabytes of RAM. And we can hold like our whole pipeline using like this small application. The fault tolerance is something that was really important when we were implementing this application, because like one of the requirements was we don't want articles without the text-to-speech version. So we need to be reliable. So that's why I built a pipeline over Elixir, because it will run eventually. If it breaks, whatever, it will run using Oban and everything. It's cleaner and more maintainable code, and I will show why in a bit. The challenge, of course, it's a challenge to do that. Why not use like only the TypeScript or use only the Java version? Of course, because we are programmers. We want to do stuff because we think it's easy, but it's not easy. But the challenge was pretty nice. The available SDKs that we have on Azure was JavaScript, Python, C#, Java, others. But we were left to use like SDKs used via ports. Probably you have like the CLI tool, which is written in Python. You could use it, implement it from scratch, and use a limited REST API. They also provide a simple REST API that works, But I discovered that they had a lot of limitations using like this REST API. The journey begins. So first implementation that we did, let's do REST API. Because simple enough. Go to the documentation of Azure. Simple REST endpoint. You post a SSML file, which is kind of like an XML, but with some tags specific for how the word should be spoken, which language, which voice. Parse the response. Ta-da! This is like the implementation of SDK. Okay, first trying, like I just got like a sent the text, got like the audio back. Woo, worked. But now I want to recognize what was spoken on that text also. So on the API, they said, yeah, you just like pass like this header pronunciation assessment. You can see here, like you have some options like a granularity, dimension, like. Which, funny enough, there is like a zero documentation about it, so I have to see what everything like this means, because like the SDK documentation, they did not explain what granularity was or what dimension was. So really nice to implement doing that. So you run it and see what it gets back. Woo! The language, okay, simple enough. Yeah, this is the talk, like this is the implementation, because it's pretty simple. Of course, it's not. We really think like it will be easy as do this, but not that easy. The good, quickly to implement, suitable like for simple use cases. Don't need like a complex connection management. It's just like a simple call. You can use a Tesla at the pool there. Works. The bad is limited to under 60 seconds of audio to recognition. So I was like, oh crap, why is this not on the documentation? And it was, but like in the really low with small letters that you should pay more and should use your SDK if you want to do this. No support for real-time streaming, which is kind of important if you want to build some apps that need to like live recognition of speech, which there's a company that is using Azure. It's a company back from Brazil. They are using it to teach kids to talk. So they are using my library to the kid like a talk, and they have like a text they need to listen to, and it will say like if the kid like spoke correctly, the words correctly, and where it got wrong. And lacks advanced features, of course. Yeah, so we need a deeper dive. We need the support for longer audio. We need a speech assessment, and also we need to stream audio. So we need to go deeper. How do Microsoft does it? Because like, okay, you have the REST API, you have nothing. You go to the SDK website, they have a pretty nothing. It's just a page with some function names, and expect this, get this out, and yeah, dude, you should just try it. Okay, you go to the author SDK, you have like these versions, C#, C++, Go, Java, woo, lots of languages, runs on browser, everything. Nice, let me check the code. No error link, no error link. No source code. The SDK is not open. The SDK is closed source, sadly. Most of the SDK, the C++ version, the Java version, everything is closed. Except for the TypeScript one. Of course, I started like with every language as possible before going to TypeScript. I went like, oh, let me check the Java one. No code. Java, C#, no code. C, for God's sake. No, and then JavaScript, no option. So let's go. Okay, it's just an SDK, right? Like you can check like the README, navigate, everything's there. 20 minutes, 20 minutes work. Let's reverse engineer it. First, Go code, I checked it out. Where is the SDK stuff? It's just a wrapper over the C implementation. So zero help. Like they have like the start continuous recognition, which like you listen for a file or from the microphone or whatever, and they call this C bindings and return, which is really weird because I tried this and I broke this like so much times. The C VM just like blows up. It happened a lot. Okay, not helpful. So only two options. Use the bindings to the native C++. We could do that using ifs, But if you ever work with ifs, you see some limitations on that. Like usually, if you don't take care when using ifs, your the interaction with the native can break your Beam VM if you don't deal with the ports correctly. It's one of the only use cases that I remember that can make the Beam VM crash. Interaction with ifs in a wrong way. So I did not want to do that. And get the TypeScript that implements everything, but it's JavaScript, so I have to read JavaScript. It was a really hard decision, like 2 days of suffering. So trigger alert, sorry. You're going to see some JavaScript now. If you feel like dizziness, if you see mutability is something really hard for you, please reach off the hug nearby Elixir dev. It will be okay. You got the SDK, entry point. Nice. It's what the hell is this? It's a callback from a promise. Good. So first entry point, you call a promise to a callback, which I don't know what this thing returns. So click, go to implementation. Start continuous, which is a promise that returns a void. So where's the audio? I want the audio. But no, the promise returns a void, return anything. It throws it, disposes something. I have no idea what this thing is. And we have this pre-reco recognize, which is kind of is an instance of a recognizer that is declared in a class, which is over this class, inheritance. Oh, look what I found. This is the function that does the text-to-speech. Oh, sorry, the speech-to-text. It gets a recognition mode, or a success and an error callback. This is so lovely because you have 2 flows, one for success and one for error, in completely different ways. So you need to treat different in your code, which is really annoying. Start everything as undefined or null, because you will mutate it later. So that's really easy to track when the stuff changes. And the code is pretty simple once you get the whole to it. It creates a connection, which I have no idea which one it is because it's an interface. And funny enough, they only have one kind of implementation, which is we'll go back to it later. It creates a specific audio node, which is, you have a kind of audio source which can be anything, and audio node which can also be anything. So it can be audio to a file, audio to a microphone or whatever. And they create this really cool class is called replayable audio node, which we will go to it later, which is such a fun class to look at. Exceptions, of course, and throws. The funny stuff is that because you have an error callback, and then you throw the exception that does not go to the error callback. So I understood it in the hard way, which is everything just exploded, and the stack trace was I have no idea what's happening. Return a promise, cancel if already exists, blah, 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 mutation everywhere, sessions. I got annoyed with this. And of course, a promise in the end to catch everything. And return nothing, of course. The functions should not return anything. Navigation. Go to 5 levels of indirection interfaces everywhere. It's a WebSocket, not documented anywhere in the SDK or anywhere in the website. Found it. It has a URI, a message formatter that I had no idea, connection adapter, an ID, and if it's disposed or not, if this stuff exists or not. So I don't care if it's disposed, I just dispose it. This is me navigating through the whole classes, go to definition, go to implementation, go to definition for a whole day until I can find this specific WebSocket. Completely loss of time. In some of those classes, I don't even remember where. I just had this script. This is how it deals with the WebSocket. It's a classic event-based application. So you connect to the WebSocket, you get a message, and you have this promise, I believe, which gets you have the text message. It has kind of a header in the response, which has which action you will execute when you receive this socket message. So you have it starts a session to listen to your voice. Every time it sends to your hypothesis, or what does it think it's listening to. So like you get like a fired up several hypotheses of what it's listening to. A phrase is when like it's certainly that's what he's listening to, and end. It has some more events related to avatars, like the movement of head and also movement of mouth for some other functionalities, but I did not add it here because like, it's really, really big. Key takes, WebSocket, lots of indirection inheritance, code all over the place. Like you had a class here that referenced the class in a completely different package just to the WebSocket. Mutations, lots of mutations. So like everything is mutable in the code. Really hard to find where the mutations were happening because everything was based on events. So you have an event that was fired in the parent class, but it was only listed in the child class. So really hard to find. Now, of course, it was 20 minutes. Starting the alchemy. Keep it simple, as simple as possible. 4 modules. Don't need more than that to implement like this WebSocket. Which libraries to use? Fresh. I don't know if anyone ever worked with Fresh. Fresh, it's a library that's over Mint. It's built using Mint under its functionality, specific to deal with WebSockets. So it helps you to create a WebSocket connection based on the gen state m from Erlang. So it's a state machine, which really makes sense when you try to analyze what the text-to-speech is and what a WebSocket is. The WebSocket is simple. You send a message, you get a message back, change your state. Like now you are listening, now you are reading, now you're analyzing. So that's why you use a state machine to do that. Nimble options, pretty simple to configure and document everything that was not documented by Microsoft, which was everything. Let's try it, simple. Create a simple socket config, as small as possible, just like the region, which format, alt key, how the recognition, get the URL of the WebSocket. This is fresh, simple, no need of indirection. You just start a link into a supervisor, and it will already provide you the callbacks. This one is just a simple handle connect, so we know that we are connected to the Microsoft service. This is trying. When you see, like I run the simple configuration, like you just add your key, whatever, open the connection without a supervision because like it's just a EX entry, and you can see connection established. And here, where I added like the inspect to set the status in the headers. Oh, 101 connection established. I could connect to the Microsoft WebSocket. Now things start to get fun. Let's make this thing work. This is like a couple of incremental, but analyzing the Microsoft code, which was like, oh, you could see the simple structure of a connection. A connection, it has like a state, an ID, it has a context, and an audio string. This was the catch. This audio string, it's replayable. So what it happens is that like their AI, it only manages to analyze 60 seconds per 60 seconds of audio. So it's their limit. So what they do is that like you have your own audio file, really pretty big, and you send it to the WebSocket, and it will analyze and it will send you back. Oh, I am at this offset of your audio file. I am at this offset. It keeps like a send to you, and it reaches to a time that it says, okay, I can't read anymore. So like this is the last offset, but you already sent your whole file probably to the WebSocket. So what you do, you replay it. So you get the offset, make a calculation based on bytes, on the bytes per second, to go back to your audio file and transmit again, starting from the offset since it's last processed, which is really hard to identify because no documentation. The implementation pretty simple. If you compare to the TypeScript one, if we go back, you see that like what they did, a simple switch case. Here we just implement the callback, which is called handle in. And this handle in, it has two kinds of like inputs, which is text or binary. Because messages can be, WebSockets can be on these two formats. They send you a body with some metadata informations, but they also send to you the binary of the file that you are like analyzing or everything. We just like created some handle paths, like a pattern matching, simple. You can see that the usage of a pattern matching makes the code way more concise on what is happening, because like each function, you pattern match it, updates the connect state in an immutable way. So like we are not like changing the connect state. We are really get the current state, put the stuff, new version, put it back on the gen server, on the gen state M. And now it gets funny. Let's compare the TypeScript versus the Elixir in a lot of the functionalities that we had like inside the SDK. Message serialization. This was one of the nicest one when you compare like a Elixir and TypeScript. This is how TypeScript does it. You get a message from your from the socket. You of course need to open a try catch because exceptions, right? It will break. The return, it's a promise that you will get a raw message. And the message has two types, which is a text, as I said, and the text is just like some headers, space, break line, the message body, or nothing. Or the message is a binary, which is really annoying to see how to calculate it. When a message is a binary, it reserves the first 8 bytes of the message to tell you what the binary is, the length of the audio, which format it is. So they do like this really weird bit shift from left to right. And this is the same. Exactly the same code, but in Elixir. If the message is text, just break 2 lines, serialize. If the message is binary, the serialized headers is just like join the text, calculate the byte size, and the pattern matching on the bytes. The first 16 bytes, the headers, which will tell you the length of the headers. Then the remaining binary is the headers itself, and the payload, which is the audio file. So this thing became this. Done. TypeScript, promise-based approach. Never solved so many deferred constraints in my life because like it's a promise that calls a promise that calls a promise. So it starts to defer to the parent promise, it defers back to the parent promise, and in the end, gets called. Separate logic for text and binary messages, just if, really weird. Manual buffer manipulation. They create a manipulation. They convert the buffer to an array, do a lot of bit shift, convert it back to string, which gets like a really complex. Try catch, no one's like that. And for Elixir, simple pattern matching, concise binary construction, functional approach with clear data transformation. So we have 0 mutations, everything is transformed. Configuration. I will never work with this kind of classes in Java, TypeScript, or everything. A class with funny stuff. They call like the internal private reference text and then like a sender reference text, get setters. Why? And of course, 0 documentation about what each class does. If you go like to the grading system, you have an enum, which literally nothing on it. What we did? Nimble options. Nimble options just like give you a concise DSL where you can document, add the valid formats, and generate a type based on it. So like you can validate the type and create it. Simple, documented. I should sell this to Microsoft. because like they really need it. Now, if you go to documentation, the XDoc, you can see like what everything does. Like now you understand what each of the options do. Yeah, advantage of Elixir I think is clear enough. We use the schema definition and validation, declarative, documentation generates automatically really nicely, easy to extend. Mutability, I think this word like kills every functional developer that says it. This is their replay audio node. And now you need to take a breath because this is really big. And I just got like the important parts of it. It's a class where you have audio string that has a buffer inside this buffer. Why? Because they need to replay it. So like they have a buffer that put the stuff, and they have another buffer which keeps track of what we already replayed on this first buffer. We will get to there. How many bytes are buffered? And if right now you are replaying, like because if you are replaying, you mutate this class and say, okay, I want to replay, so like it swaps the buffers. IDs, which is completely useless, you do not use it for anything. Need to take a breath. If it's not a replay and the buffer is empty, you should seek this offset in the buffer, mutate, run in the buffer, while the buffer exists, seek on the other buffer and put it on the main buffer that will be sent. I completely lost myself on this thing for like 2 days trying to understand what they did. And in the end, it returns a promise that they will have a buffer at this time. So what they do is pretty much, you can just see some calculations here, that you get an offset from the API, and you convert this offset to a time inside your buffer, which you calculate based on the bytes per second and on the amount of channels in your audio. So you get like a kind of like the position on this audio. I thought it ended. No, it's still part of the same class. They can shrink the buffer because what do you do? What you don't want to do is to have like this audio in memory, the full audio in memory all the time, right? Because audio is pretty expensive, it's memory. So every time that it reaches an end of an audio, of what it processed, you go back to the offset that you said, okay, you should go back to here and discard everything that is before. So you keep only this audio part over it. So this is how it works. And like this find time of offset is like a kind of a convert, blah, 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 everything. This is the same class in Elixir. Simple, 2 functions in a string. You calculate pretty simple the next step, the next part based on the offset. Because what you do is that every time you receive a speech that it identified, it tells you like where it ended. So like you can know exactly on your voice where this specific audio is. You have like 2 small cases. The first one, it's you can see that there's a guard just to identify when your buffer ended. In general, because like if it ended, you should just like go back to the other one. And to shrink, just like get the offset, bytes per 100 nanoseconds. You get like the binary part, just make a small calculation, start from here, discard everything else, new state. That's so like this whole thing became this. Expressivity, I think it's clear. It uses like an array buffer with a manual offset, which is really complex. It mutates the internal state a lot. And the issue with mutating this internal state, if you don't deal with about like a Node.js has like a single event loop, it can get like a really, really annoying to maintain this. And also to evolve, because like mutations, you don't know where this data is being mutated if you have like 200 classes there. And string processing, simple string module. Function clarity. This is how you call the SDK in TypeScript. You create a function like this is like just instantiate. This record is a simple instantiation of the class, where you pass the configurations. You create a function that will be the callback, and you need to get like this callback into a function that will process this callback. So it's really hard to know what it is being built there. This is the same. This is like you can get this on the test. It's a simple processing on a string on Elixir, and you can do the way that you want. Do you want to send to the message box and process it? You can. Do you want to collect it to a effectful enum? You can collect it, and everything is already documented. It's typed. The structure is completely typed. Final takes. We can see that like the concurrency model is like it's ideal to manage like WebSocket connections. Why? Because here every flow it will be its own process isolated on the Beam VM. So they will be scheduled, isolated, supervised in an isolated way. Will run by itself. If something breaks, it will not affect any other process. The pattern matching, it helps a lot with the processing the binary itself, because the binary, they are patterns. So in some other implementations in the Speech SDK, you need to know what is like the format of the audio, what you have like in their metadata. So you can just pattern match on the bytes themselves. Pretty easy. No need for several layers of indirection. So you don't need like a go to definition, go to definition, go to definition, everything implemented in 4 modules instead of like I don't even know how much. Like, of course, they implement some more stuff that I didn't. But if you go like to the same flow, you can see like the implementation is way higher, way like larger. And it works, of course. Like we have in 24 hours more than 36,000 requests for analysis, text to speech, speech to text, without any issue. With running like a simple pod, pretty small, no need of anything else. That's it. You can reach me through my email, my LinkedIn, also GitHub, and also if you want to contribute, because everything is open source, feel free. It's also in my GitHub, Azure Speech, also the RavenDB one, if you find it interesting, everything's there. Thank you.
All right, we have about 5 minutes for some questions. Yes.
Hey, thanks for the talk. I was wondering, I didn't quite understand conceptually from the Azure API, is there a reason that they do this whole replay, that you send the full file at the beginning and then you have to replay it from there and there and there? Why don't I just send the first 60-second chunk and then the second one and so on? Mostly because you don't know when it will stop processing. Okay. Their AI is kind of exclusive source. You don't really know. If you go to their SDK, you just like fire your own buffer and you keep firing to this WebSocket. It can be that like while you are still firing, it will already answer with a piece of what you expected. But it can be that you already fire like everything, and like it just returned the first phrase, and then like their WebSocket just like I say, okay, I'm ending recognition, send me the next one. So what you need to do is like, okay, let me go back to where like you last like understood it and fire it again. So that's why we need this replayable. It's mostly because their AI, how it works.
All right, more questions?
Thank you. First of all, great accomplishment that you managed to go through and didn't give up after all seeing the JavaScript and TypeScript and no documentation.
Almost did.
But I was curious, was there a particular reason you chose for Azure?
It was kind of like the company-wise decision. We had some different vendors, and Azure offered the best solution for text-to-speech.
Thank you. And can I ask another one? Where is DPG using it for? Is it for generating automatically the subtitles, or?
We use it right now to generate the
audio from an article, an existing article. So it generates a listening way of this article. I implemented, it's not like in production yet, which is kind of like you generate the audio, and you can run another AI from Azure, which is the recognition, to see if the generated audio is pronounced correctly. So they kind of like do a loop. But sadly, they're not that good for Dutch yet. But they are working on it, so that's why I'm waiting.